Okay, let's see whether um, let's see whether you guys can hear me. Can you all hear me? If you can you just leave just a comment in the chat so that I know that you are able to hear me? Oh, great. Okay, okay. So let's see whether how long this goes. It keeps telling me that this stream is going to end shortly. I don't know why. So let's get this started while we can. So I'm going to go look at my document and hopefully it will change. So first of all, this first question, it's very important to identify what the status quo is. And so the thing that we want to check is whether there's any support for the hypothesis that 70% of Hope students have never left the United States. So to test this, we take a sample of 135 students and we find that 97 of them have never left. So this one is pretty basic. It should be something that you're used to from school. The proportion is 97 out of 135 that you observe. This is observed, and so the symbol is just p. Okay, so what is the population of interest here? I hope you realize that in this case it's all Hope students. This is a tangible, what I call a tangible population, a population that you can actually touch and see. And so we want to see whether there's any evidence for this or not. Okay, so let me continue. Once you have the sample proportion, the parameter of interest should be identified, and I hope you have that the parameter is all of Hope. What is the proportion in the whole school that have never left the US? Since this is a proportion, the symbol we should use for this is pi, all right? So the next important thing to note is what are we trying to test? So what we are trying to test now is whether pi is 0.7 or is it something else, right? So the thing that you want to test is the thing that the question says. You want to see whether 70% of Hope students have never left the US, you see? So this is a statement about the population. Do you think the observed proportion is likely if the percentage of students who have never left the US is really 70%? So we find that the answer should be, well, 71.85%, that's your 97 out of 135. 71.85% is quite close to 70%. So do you think this is a likely thing to see if the percentage of people really in Hope who have never left the US is 70%? I would say, yes, I think this is quite likely. It's very close to 70%. So then the next question says, okay, can you give me some examples of things that you're unlikely to see if what you say is that Hope students, there's 70% of Hope that's never left the US. So here are some very unlikely ones, right? Either very low or very high. Okay, so next we'll discuss what happens in the simulation app, and you will find that the value of pi you should set is the one that you are interested to test. All right, so pi equals to 0.7. Someone asks, is the live stream being recorded? It should be, and so but you can see it at the end. So I hope it's more stable now. So I just want to see whether I can just sort of ask you guys questions and you can respond in the chat. All right? So let me again go back to this one. So I hope you realize that when you use the applet, you should use pi equals 0.7. That's the thing you want to test. You should use n is 135, and you should be seeing something like this. All right? So you can see the 0.7 there, and then the sample size 135, number of samples 1000 as usual. So now is the important part. What now? Again, someone asked me why is there a most recent results. Just ignore this part, right? Ignore this part. The most recent results you don't look at. So the important thing is to evaluate how often do you see something like 71.85%. That's what you actually simulated, you see. Sorry, that's what you actually observed. Sorry, that's what you observed. You have so many simulations here, simulated at the status quo value of 70%. So you want to check where 71.85% is, you see. And we find that if you look at my picture, and yours should be quite close to this, you should see that you get this about 35% of the time. So what does this tell us? 35% of the time means getting something like 71.85% never leaving the US in your sample. It's not a very special thing when your value of pi is at 0.7. Right? So you see what I say here. Based on your simulation, would you reject the hypothesis that 70%? I don't think we can reject it, because this kind of thing happens all the time when the truth is 70%. Right? So that's the logic behind it. Okay, so let me go now to the second question, which is the one that says test the same thing, but now we want to test whether is it true that 65% of Hope students have never left the US. You will find that the same data is being used, so there's no change in the observed proportion. It's still p hat equals 97 over 135. Okay, but let me ask you some questions. What is the population of interest? Did that change? No, it didn't change. It's still all Hope students. Define the parameter of interest. It's still the same. All these questions have not changed. Write down the hypothesis that is made. So I hope you have that as 0.65 for the value of pi. That's the new thing that we want to check. All right? That's the new thing that we want to check. Okay. So now let's go on. Do you think the observed proportion is likely if the percentage of Hope students who have never left the US is 65%? Now, notice that 97 out of 135 is still 71.85%. That data hasn't changed. But now we are trying to check whether the hypothesis that pi equals 0.65, does this often give you something like 71.85% when you simulate? Right, so this is what I want to ask you to tell me in the chat right now. If you have done this, what is the fraction of simulations that you had where you get 71.85% simulate at 0.65? Can you all just add your answer to the chat? Just let us see what did you get for that one. See whether that's something that you have that I just want to compare your answer with mine before I show you mine. Can anyone want to try? Just add your answer to the chat. What is the fraction that you get when you simulate at pi equals 0.65? What is the fraction that you get, which is at 71.85%? You know that red line? Let's see if there's anyone that has any answers that you can just share in the chat session, and we can see. Right, I'll give you a minute or so. Okay, so I've seen an answer 0.062. That sounds about right. So let me show you my answer, okay? So if you look at my answer, you can see that I'll blow up this part about a little bit. So can you see that here, see everything is being simulated now at 0.65. Thank you, Grace. So everything is being simulated at 0.65, and you can see this is still comparing at the observed statistic, which is 0.7185. And you find that there's a smaller fraction now. I had 52 out of 1,000, which is about 5%. And the answer given by Grace was she had about 6%. See? So it's much rarer now to happen like that. It's not very common that you get something like 71.85% when you assume that pi now is 0.65, you see? So state a fraction of the times. The fraction for me is 5.2%. Yours will be slightly different, but it should be kind of the same value. Report the SD of the simulated proportions. This may be something I have not mentioned in every class. How do you get this SD? You get this SD by actually going to the proportion of, change it to proportion mode, and then just click summary statistics. That will give you the SD. So if you did not do it last time, now you can do it, but just make sure that you're in proportion mode when you do that. So based on this simulation, would you reject the hypothesis that 65% of Hope students have never left the US? I think I would. Why? Because this kind of thing doesn't happen very often. Getting 71% in a simulation when you assume pi is 0.65 is not very often done. It's not very often happening, and so this gives us a clue that, yeah, maybe the null hypothesis that says that 0.65 is the fraction of Hope students that have never left the US should probably be rejected. Okay? So don't worry too much about the details. There'll be some more coming in class tomorrow. It will make things a little bit clearer after that. All right. The next one we're going to look at is the one about buttered toast. Okay. So if you look at this question, again, let's start with something simple. We want to test what? We want to see whether in the long run, in the long run, will a piece of toast land butter side down half the time? Now that's very important. See, half the time. So hang on to that number. So what did we do? We did a crazy thing. We take buttered toast, 60 slices, 60 of them, butter on one side, dropped it on the floor, and 38 of those times the toast did land butter side down. All right? So this part's easy. What is the observed proportion that landed butter side down? You should get 38 out of 60. What's the population of interest? This is a different kind of population. It's not like Hope students. This is the entire collection of all possibly dropped pieces of toast. Yeah, I know it sounds really weird, but that's it. The population is every possible piece of toast that you could possibly drop. Okay? So what symbol do you use for this parameter? It's a parameter, it's a proportion. We always use pi. Now this is important. Write down the hypothesis that is made in the question for the value of pi. What did we say? We want to test whether in the long run a piece of toast will land butter side down half the time. That's how you know that that's the status quo. You want to check whether pi is 0.5 in the long run. So this question is always, do you think it's likely to see things like 38 out of 60 happening? Now, 38 out of 60 is 63%. 63% is really quite far from 50%. So do you think it's likely to see something like this when you simulate using a process that's really 50%? I don't think so, right? I don't think you see this very often. Then I asked some other questions. Can you give me some fractions which are unlikely to be seen if really half the time the toast lands buttered down when you drop it? Well, anything far away from 50% will do. Either very, very big or very, very small, like that. So now, let me ask you the question. In the simulation app, what's the value of pi that you should be setting? So let me go to the chat. Can you tell me what the value of pi was that you should set pi to be? Just say pi equals something. Can you put in the chat? When you try to simulate, what is the value of pi that you should be setting in your simulation, right? To see whether you get things like this when you assume that pi is as the question says. Status quo says pi is what? Can we have someone? Yes. Again, thank you, Grace. The chat, if you look at the answer is you should be setting pi equals 0.5 in the app. All right, because that's the status quo thing that you're trying to check. So pi, and I hope you know n should be 60 because that's the number of times we actually did the experiment. We dropped a piece of toast 60 times and we wanted to see how many times it lands butter side down. So you should be getting a picture like this. See, you set pi to be 0.5, that is status quo, sample size is 60, and the number of samples, as usual, something large. So you see, why am I comparing at 0.6333? because that's the thing we actually saw. 0.5 is the status quo that we're trying to check, but 0.6333 is the thing that we actually saw. So you can see how often is the fraction of times that you actually see something like this if you assume pi is 0.5, right? Can you answer that question? You can see the fraction of times is just 2.5%. If you look at this part, 25 simulations in 1,000 produce something like that. All right? So the fraction of times is only about 2.5% of the time. Therefore, do you think we should reject the null hypothesis? I would say yes. Why? Because, see, it's so rare that if you really say that the buttered toast will land about half the time on the butter side down, but here you are seeing 63%. This does not happen very often when you say pi is 0.5, you see. That's the rationale. It only happens about 2.5% of the time. And so the rationale for that is, okay, because it's so rare, I am going to reject that hypothesis. You can repeat the same question, but now with the testing the status quo that, well, maybe butter makes the bread a little bit heavier on the buttered side, so I'm going to see whether there's any evidence that it lands 55% of the time that way. So again, the data didn't change. I didn't change the experiment. I'm just testing something else. So I still have 38 out of 60. The population is still the same. It is the entire collection of all possible drops of buttered toast. What's the parameter of interest? Still the same. In the long run, what's the proportion of toast that lands butter side down? And what's the null hypothesis here? You now want to test whether pi is 0.55. Right? Do you think this is likely? I would say, well, perhaps it's a bit more likely. Isn't 63% a little bit closer to 55%? I would say yes. So give an observed proportion unlikely to see, same answer. Anything far away from 55% is unlikely to be seen when you simulate at 55%. All these are very small percentages or very large percentages like that. All right? So in the app, you should be setting a value of pi like 0.55 and 60. So can I ask one final question? What is the fraction of times where you see something as extreme as this? See whether anyone can tell me the answer. What is your, basically that fraction in red, when you simulate at pi equals 0.55 now, and you still have your p hat at 38 over 60, can you give me the fraction of times you had something as or more extreme than that? You know where that red line is? Can someone give me the fraction? You can give it to me as a fraction, or you can convert it to a decimal and just report your answer. Right? Let's see whether your answer is close to mine. Right? Just put your answer in the chat box and we will see. Right? What kind of fraction do you get when you simulate at 0.55 and then you look to see what happens at your thank you. So Grace got 0.125. Let's compare it to mine and have a look. That is so creepy because mine is almost exactly the same. See, I had 0.123. Simulation is like that. Your answers should be close to mine or in the same ballpark, all right? Not exactly the same, but what does this tell you? It means that when you assume that it's 55% that in the long run will land butter side down, and here you are as observing 63%, this happens about 12% of the time, and that's not very rare, and so that doesn't mean that 55% is unreasonable. 55% could be a reasonable value, and so do you reject the hypothesis? And I would say no. Now, I know that this session has gone quite fast, and I'm even surprised that nothing crashed. So I am going to end the stream, but please don't worry. If you have questions about this, you are more than welcome to please come for office hours. Cannot make my office hours, please find some other time and I will definitely help you. I will also be covering this kind of thing in class again tomorrow for those of you in 115. And so it will get better. Don't worry. I think those who logged on already, so I hope that you have learned something. This stream will still be available, I believe, at the same URL once it's over, and you can watch it again. Please come for office hours if you want further clarification. This is something that will get easier as time goes by. So I will see you all tomorrow or Wednesday, depending what class you are. Thank you to those who participated, and I will end the stream now, okay? Thanks.